Everyone, May the 7th. Alright. I'm gonna say maximum. Matrix diagonal sum. Given the square matrix, return the sum of the matrix diagonals. Only include the sum of all the elements on the primary diagonal and all the elements on the secondary diagonal that are not part of the primary. So I probably have to not count the middle one twice, right? Okay, so all of these, if I remember, they have the same I and j. All of these, I think it's either I plus j is the same or I minus j is the same. I'm not sure. Okay, this is 0, 0, 2, 1, 1, 2, 0. No, the sums are the same. Sum is going to be 2. So yeah, we can go through this and then we do the middle. Oh, depends. Some of them don't have middle. It was actually quite interesting. Some of them do not have middle, depending on whether it's even or odd. So there are two things happening here. Of course, if you really want, you can definitely do NumPy, but let's just do a stupid way. Okay, never mind. What we're gonna do is n equals the line because it's a square, so it's gonna be same. So total, I can say res equals 0. Right? I'll say for I in range n, res plus equal to mat I. This doesn't gonna work. And for I in range n, res plus equal to mat I. Okay, this is shall be n minus 1. Okay, that's the sum minus I, right? Because we start I is 0, n is 3, 3 minus 1, 2, 2 minus 0 is 0, 2 minus 0 is 2, so we start with 0, 2, and then I become 1, and then 2 minus 1 is 1, and then I become 2, then 2 minus 2 is 0. So we do that, and then we say if n is odd, right, then res minus equal to mat n minus 2 and n minus 2. Like this, we have 3 divided by 2 is 1, so 1, 1, we have to remove the double count, then we return res. Okay, let's see if it's right. Okay, shall be right. Why so slow? No clue. If you're telling me you can do it faster than this. Okay. Yeah. What else can you do? Oh, okay, I gave it to you. You can do it once. All right. Yeah, that's actually true. $15. I bet people using NumPy for this. We can actually try NumPy. No. Let's see if it's just gonna be faster. I don't think so. It's the same thing. It's exactly the same thing. Yeah, it's the same. So probably NumPy. Okay. Let's do NumPy here. NumPy. Ooh, NumPy diagonal. Actually, I'm not sure. NumPy opposite diagonal. Do we have that? Flip. Ooh. 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 Okay, so we need to use this. Flip left and right. Ah, yeah, you flip left and right. Or you rotate 90 degrees. Because opposite is this, you rotate 90 degrees? Yes. You flip left and right, yes, both works. So let's say import numpy as this. We can say res equals to numpy.diag mat numpy.array mat plus numpy.diag. We're gonna flip it, and then if this is that right, n is not defined. Oh, Jesus, man. I forgot our sum. Ah, we can actually add them and then do one sum. Alright? Is this okay? Oh, but numpy you have to load, so the loading might be slow. It's slow. Doesn't matter. Okay, so we're done with this. Number of ways to earn points. There is a test that has n types of questions. You are given an integer target and a zero-indexed 2D integer array types, where types I, count, and marks, indicating that there are count questions of the ith type, and each one of them is worth mark points. Return the number of ways you can earn exactly target points in the exam. Since the answer may be too large, we have to modulo it. The questions of the same type are indistinguishable. For example, if there are 3 questions of the same type, then solving the first and second question is the same as solving the first and third question, or the second and third question. What does this mean? It's a different ways. So you don't distinguish between, so it actually makes things a little bit easier. So you can earn 6 points in one of the 7 ways. Solve 6 questions of the 0th type. Solve 4 questions of the 0 type. 1 question of the first type. 2 questions of the 0 type. 2 questions of first type. Is this like knapsack? What do you think? Basically, we're saying we have 6 stones of weight 1, right? We have 6 Why is it not working? Okay, now it's working. I'm not sure what happened. Doesn't matter. All right, so what we're talking about, we have 6 stones of weight 1, 3 stones of weight 2, and 2 stones of weight 3. Now we want to know the total number of ways to fit a bag of limit 6, right? Perfectly. So basically you can say, okay, we say if I take, because for stone of weight 1, right? I think maybe it'd be something like this, right? Weight 1 we have 6, weight 2 we have 3, weight 3 we have 2, right? That's a counter. And I can say I take weight 1, so I can take 0 for weight 1. Okay, what's the 1000? I can take none of this, or one of this, or two of this, right? So I can say I'm at the index, right? This will be index, so it'll be dp index and the remaining, right? And at each index, you can go through every single one of these. But hold on, how many do we have? Target is smaller than 1000. N is types.length. Mark count is smaller than 50. Yeah, we have with an index. You can say for count in range. This should be counter, right? Counter, which shall be marks index, right? So we can say we take 0 of this, right? 1 of this, 2 of this. Maybe. Let's give this a shot. Okay, I need a counter. Okay, then we need to do a counter for count mark in types. Okay, then counter. Then we say counter mark equals C. This is the number of count, right? And then we say marks equals sorted the keys of counter. Okay, then def dp, we have index remain. What do we return? Return an int, right? So when we say if index is larger or equal to landmarks, we go out, return 0. This nothing works. If remaining equal to 0, that means it works. Then we shall return 1. Okay, and we shall say for each index, we say for count, right? For used to use, num to use. Okay, num to use in range counter. Counter what? Counter marks index. Wait, you don't need to sorted it. Why would you sorted it? It's okay. Don't need to sorted it. Right, for counter this. So I take a 0, take a 1, take a 2, doesn't really matter. And then if this or remaining smaller than 0, right, that's all bad. Okay, rest will equal to 0. And I say I have this much to use. I only use this much, right? Now we'll go to the next one, which is dp index plus 1. Then remaining need to minus num to use times marks index. Right, that's the remaining. We have that much. So res shall equal to res plus this. Okay, mod. Right? As every time you use this, what's the total number? Every time you use this, what's the total number? And then every time you use this, right? Okay. While we're doing that, we're gonna return res. No, cache this function. Then we're gonna do BP. We're gonna start with 0, remaining as target. Right? Can we just return this? Ways, oh Jesus. Ways to reach target. That's very bad. Something is not right. Okay, that's okay. Let's see, what goes wrong? Let's investigate. I don't know. Right, we start with 0, 6. Index is 0. And then 1, 6, 2, 6. 3, 6. That's done. And then we do... Wait, what's the marks? Marks is 1, 2, 3, right? We have 1 mark, 2 mark, 3 mark. Okay, that's fine. So to use, so we'll start with 0, right? And then we should be 1. If this is a 1, it should use 1. Number 2 is 1 times marks index. Marks index is 0. So we shall see a 5, right? We shall see a 5. We shall see a 1, 5. Yeah, we have 1, 5. We have 1, 0, 2, 0. Yeah, we only have let me think. Why is this not right? I have 2. Well, I mean, I shall have a 2, 0. Yeah, that's all 6 used. How about 4? I use 4. If I use 4, then I shall have a 2, 2, 2, right? Do we have a 2, 2? Yeah, we have a 2, 2. Okay, if we come in 2 and 2. So number to use, not 2 and 2, 1 and 2. 1, 2. 1, 2. Yeah, we have 1, 2. 1, 2. And I use 0. That shall be 2, 2. Wait, hold on. Let's not cache it. Maybe it's the cache's issue. Nope. Oh, we are in we're at 1, 2, right? We're at 1, 2. Okay. So 1, 2. Marks 1 is 2. Counter 2 is 3. So I have 3. So we can use 0. Hold up. Let's see DP. One. Remaining 2. What is this going to give us? So we have 2 remaining, and I have this. That's actually true. We only have 1 result. Yeah, we have 2 remaining. So that's 1. Okay? Which is this case. How about this case? This case is I use 2 of 1. Okay, so I should have 4 remaining. So what if we have 1, 4? Yeah. 1, 4 should have 1 as well. But why is not? Hold up. This doesn't make any sense. How about 1, 3? I have a 3, 0. That is perfect. I have all of these. How about I'm going to have 2, 6. No, 1, 6. Position 1. That is very interesting. This does not return true. I'm at position 1, right? I have remaining is 6. When that happens, counter marks 1. Marks 1 should be 2. So this is 3. Then we go to 2. That should give me 3, 0. 2, 0. Where is 2, 0 here? Hold up, that doesn't make any sense, right? Num to use 1. Okay, let me also do num to marks. I want to know the current marks as well. Right, so I have, this is the current mark. I want markers 2, 1 to use. Markers 2, 2 to use. Oh, we never go to 3. Holy crap. And a plus 1. Damn. Dude, if that is the reason, then now I'll be very pissed. Well, still not right, but I think we'll get a little bit better than this. Okay. Doesn't matter. Let's take a look at this. We have 2, right? 2, 0, and 3, 0. We got 2, which means when we go to 1, 0, which we don't use any 1, right? If we, Is there any like multiplication thing going on? Yeah, I mean, don't use 1. We have this, and we have this, right? 2. Now to use 1. I have this. I think I have this. Okay, 1, 0. There's this. 1, 2, 0. I mean, this is 2, 0 is called once. That's understandable. You know what? That's not the one we wanted to go. Let me do it this way. Yeah, we have this much to use, and this is how much. So let's call it n equals this. I want to know n, right? We can print. Let's print marks num to use, right? And probably remaining. And how many we have done. Okay, and this we can just say this is fine. Okay. We say, okay, we have marks index. We don't need marks index. I just need to know num to use. Oh, no, it is necessary. So why the 3? Marks 3. Num to use 0. Doesn't make any sense. Index. Oh, I do this one first. That's why it doesn't make any sense. Anyway, so we are indexed at 2. Say index at 2. Marks as 3. Num2 is a 0. That gives us 0, it's correct. Okay, index at 2. Mark is 3. Okay, I just need to know mark. Okay, mark is 3. Those are the only 4 situations that... No, look! 1, 2, 3, 4, 5, 6, 7. Oh, I see why. I only collect, this is how much. Oh God. Now I know why. I know why. There we go. Wait, is it only called once? Let me just double check. 3 0 1 2 0 1 0. Yep, I think it's fine. Oh, this is time wasted. Oh my goodness. Okay. Why is this wrong? Okay, how about this one? I got 7. What? Oh, that was 0 6. Jesus, man, target. Ugh, still not right. Ugh, still not right. Target 18. Answering all questions. Huh? Hold on, let me think. I see. I see. I see. I think this one shall go first. No. Lordy. That's not right. That's not right. Yeah, because it could be I answer the last one, right? Minus this. And then go to the next one. And then remaining becomes 0. Why would that be 3? Hold on, let me think again. There's only 1. Probably it's called 3 times. Let's see. Okay. 2 6 and 1 12 and 0 18. What does this say? I think this probably says I have to separate them out. I cannot write it this way. Which means I have to do a DP table. Okay, so DP table. Index and the remaining, right? So index could be rows, remaining could be columns, and columns is 1000. Okay, so 0 times target plus 1, and this for this in range what? Len types. Okay, so don't do this. Probably -1. All right, so if remaining is 0, okay, then we will set, okay, first of all, if dp index rem is larger equal to 0. Return dp. Okay, I can do if this is smaller than 0. Okay, then we do all of these things. Okay, if this, then we say dp index remaining equals 1. If this, we say it's gonna be this 0. Okay, elif, right? Else, we say for num blah blah blah. Rest equals rest plus this. I mean, we don't even need to return a value. We can just set up, I can just do this. I can just do this, right? We'll do the dp thing first. And then dp index rem equals dp index rem plus dp index plus 1. Next rem equals this. Next rem. All right. This is easier. All right. And now I have to return. Close this mod and blah blah blah. Once we're done, let's not do this. Definitely don't do this. We'll return dp index and remaining. Okay, now once we're done, we're going to say this. Rest equals to 0. Okay, for I in range, len types, when I say rest equals rest plus dp I target, which means we'll always use, then I don't need to use this, right? I have to use, wait, hold on, we have to use one of it plus 1, right? We always use, we have to use index, right? Either 1 index, 2 index. You know what? It's actually fine. I can use a 0 index. Because all I need is to know if I use, if I use the first. Now I have to use the first. I have to use the first. I have to use each index. I either use 1, use 2, use 3, or I don't use the first. So that's what happens, right? If I don't use the first, I'll go to the second one, then I don't use the first. And then I'll return rest. Does this one work? Function is not subscriptable. What happened? Oh, dear Lord, this is memo. Oh, screw me, man. List out of range. Well, probably need to get it a little bit bigger then. Dear God. What is this? Oh, negative value. Ah, gosh. Okay, I'll set it to 0 first. If it's 0, then we set to 1. Okay, then we say if this is smaller than landmarks, and this is larger than 0. We do this. Okay, this one looks promising. Oh God. Alright, we have to do something beforehand. Hold on. So what I think I need to do is if remaining equal to 0, right? And if index what happened? Index and remaining. Oh, the second one wrong. The first one is wrong as well. Oh, screw me. Hold on. Let's check whether what is going wrong. 5. 1, 2, 3, 4, 5. That's good. And I 6, so it's the 3. The 3 is the issue. Okay. 3, 6. No, 2, 6. Index is 2, right? Index is 2. 2. Wait. That's fine. It should be landmarks. It's the same thing. That's the landmarks, but that's the same thing. Index is 2, right? So DP 2 and 6. If it's equal to 0, right? And then we'll just say, but now remaining is 6. Index is small, index is 2. Remaining is 1, yeah? For number to use, I say I use 1 or 2, right? And I use 1. Next remaining is remain minus 1 times 3 will be 3. Okay, then this will be plus 1 for 3, right? It comes in. This is smaller than 0, and not 0. No, because it's already 3. So I finish. Now return. That will be 0. right? But then I can also do 2, right? I can also do 2. I can also do 2. I have 2, 6, 2, 6, 0. If I have, this is 2. 2 times 3 is 6. That'll be 0. Next round will be 0. And this will be 3. So come in, I set this to 0. And I say rem is equal to 0. That's true, so it should be 1. Wait. What happened to 3 to 2 3 3 minus 1 301. I have 301. I have 301. I don't understand. I have 301 already. Dude, this is ridiculous. Yes. Yes. And this becomes 0. What the hell? Something got overwritten. But how? Okay, 0, 6. And we have, this is a 1. This is also 1. That's 0. 1, 1, 0, 2, 0, 3, 0. That is correct. Alright? Now we go for 1, 6. Because 2, 6 is already 0. 2, 6 is already 0. Why would 2, 6 be 0? Two, 6 is already 0. 0, 1, 2. 0, 1, 2, 3, 4, 5, 6. 2, 6 is 0. What? What the hell? I mean, I never go to 2, 6. Seriously, I never go to 2, 6, right? I don't have a 2, 6 here. Then why 2, 6 will be 0? Okay, I don't understand. I don't understand at all. Where does the 2, 6 takes place? Oh, here. One, 4. 1, 4. Wait, how? I don't understand. It doesn't make any sense. I never called 2, 6. Then how does 2, 6 gets updated? You know what? Maybe it's because like someplace +1 is causing the issue. I don't know, man. I really have no idea. This is as weird as it gets. So it happens after we go 2 minus 1. So we do 2, 1. Okay. 2, 1, we get -1. And 2 minus 1. Oh. I think I probably know. Let's just handle it on the outside. Dude, this is just way too... No, it has to be... No, hold on. The problem is the 2 minus 1, right? Yes. I think remaining is smaller than 0 need to be checked first. Okay? If remaining is smaller than 0, we shall return 0. This is no question. We shall handle that first. And then we're going here, right? So if it's smaller than 0, that means it's not been checked before. Then we'll set it to 0. Okay. And then we say if this, then we set it to 1. Otherwise, we say if this, then this definitely, right? If this, then we'll do this. Now 0, 6 become 4. It's supposed to be 5. So 1, 2, 3, 4, 5. It's supposed to be 5. Now it become 4. What the hell? I mean, this is good, so we don't do this anymore. This is good, but this has only become 4. Okay. 3, 0, 1, 2, 3. Index is 2. Remaining is 3. Have 1. Index is 2. Remaining has 3, so I have 1. That's correct. Index is 2. So we have 1, 2, 3, 4, 5. Now I cannot count this way. Right, so we start with 0, 6. Okay, 0, 6. And then we do 1, 5. Right, 1, 5. Take 1. 1, 5 should be 1. 1, 5 is 1, that's correct. Then we have 2, 4. Right, we take 2. 2, 4 shall be 1. Where's 2, 4? Where is 2, 4? Why is there no 2, 4? Why is there no 2, 4? Then when to use 2, 2 times 1 is 2. That's 4. Oh, 1, 4, not 2, 4, 1, 4. 1, 4 is 1, okay? So 1, 5, right? We have 1, 5 is 1, 1, 4 is 1, that's good. How about 1, 3? 1, 3. 1, this is not right. 1, 3 is 0 is not right. 1, 3 should be 1. Okay, why does 1, 3 doesn't work? Okay, so if we do 1, 3, right? We do 1, 3, because if it's 1, 3, you require this to start from 0. That's why. Now we get all 7. My God, I'm not sure. The whole thing is, it's so simple, but I get confused. I mean, if you're talking about this, then we can actually memo it. I don't know, it just feels so weird, right? It's so simple. I don't know what happened. Why you got it so wrong? I think it's because the condition check was wrong, right? The first check is remaining. Remaining is smaller than 0, of course. Remaining is 0, of course, right? So whenever remaining becomes 0, we're always going to be good. Remaining smaller, always bad. And index, if it's larger, then that's going to be bad. I mean, it's not going to be, so we can actually just say it's equal to, then that's bad, right? And now we set to 0. And then I basically just say, okay, I want to know. So this result is the total number, right? We're starting from 0, how much we can get. And the total number starting from this with this, how much we can get. Yeah. It's a simple problem. It's not difficult at all. But yeah, sometimes I just, not in the best shape and just, just struggle. It should be very straightforward. Unless we time out, that's a different question. Okay, that's not a... The hell is that? First type, second type. Yeah. I think you shouldn't use a counter. Okay, so what we have is types index 0 plus 1 types index 1. There. It's not hard at all. I mean, this is not difficult at all, but I struggled tremendously because I messed up with the edge case checks. I mean, this is a very typical, right? Typical DP problem. Nothing special, actually. Index n times t, right? I mean, runtime is pretty bad, so maybe there are better solutions. I am not sure. Knapsack. You can do one-way DP. Oh, I have another count. Yeah, I have another count. Target return 1. If it's large, or this returns 0. Yeah, you can sum. That is true. Yeah, it's a pretty simple one. Alright, yeah, it's pretty bad. I struggled so much. It's such an easy one. Okay, that'll be it for today. I will